Hi everyone, for this question it said by using the Newton-Raphson method with initial value at 2.5, approximate the real roots of the equation ln x equals to 3 minus x, correct to the 3 decimal place. So Newton-Raphson method formula is given here as n plus 1 equals to Sn minus the function in terms of Sn and the first derivative function in terms of Sn. So first of all, you need to obtain your function. Given here is a equation. So to get function, we move all the term from the right hand side to the left hand side. So ln x will be plus x, then minus 3 equals to 0. So when it equals to 0, we can define it as a function here. Then what do we need to do next is find out what is your first derivative function. Differentiate this function with respect to x. Differentiate ln. We take the function from the log here and then differentiate it at numerator. We get 1. Differentiate x. We get 1. Differentiate constant. We get 0. So for this fraction, we can simplify into a single fraction here. So here, denominator we time with x. Numerator will be time with x also. Then with the information given here, initial value, so means x naught is equals to 2.5. Then we continue. We need to approximate to get the real roots from this equation. So we need to use the Newton-Raphson formula to find out what is your x here. So to get your x1, it will be your x before this, which is 2.5 minus your function ln 2.5 plus 2.5 minus 3. So this is your function over first derivative function. So 1 plus 2.5 over 2.5. So make sure you write your step in clear and full. Then we press our calculator here. So we know we are not pressing the value, we are pressing the formula. We start with alpha x to represent this as n, and then minus fraction, the function. So function, we put in the function here, ln alpha x plus alpha x, then minus 3 over, denominator is a rational, where it is 1 plus alpha x over x. Then we press calculate to substitute our initial value 2.5. So here we have our first answer 2.2026. So final answer, let it to be 3 decimal place. Meanwhile, in calculation, we're going to plus 1 or maximum plus 2 as 1 decimal place in calculation. So normally we'll add once 2. So 3 decimal place, I will add once until 5. That is the maximum. 202649. So round off become 5. So here we have 3 plus 2 at once decimal become 5 decimal. And then when we continue to x2, we're going to substitute this 2.20265 into the Newton-Raphson formula. So again, ln 2.20265. Make sure you write your step again. And then we press calculator, calculate. So press key in your value that you want to calculate, 2.20265 equal. So now we have new value, which is 2.2027992 2079, and then 38 become 4. So we're going to repeat the procedure x3 until we get a repeating x here. So that is the x that we managed to approximate to the real roots for this equation. So for the third approximation, we just press calculator, calculate for 2.20794. So again, we get 2.20794. So once it is repeat, which means that we can stop our calculation. So this is our stopping criteria when we have repeated x, and we conclude out what is the x value that we're going to take, which is 2.20. So final answer in 3 decimal place. So directly round off for 3 decimal place, 2079, it will be 208. So this is a 3 decimal place. You have to show it in the last working in your conclusion here. Then we're going to see what is important in these questions. So 5 marks. The first mark is obtain your first derivative function correctly. So this is your basics here. You must have this kind of function so that you can get it correctly. Then secondly, perform the concept of Newton-Raphson method and get the first approximate answer. And then the next one will be the working for us to see you doing the second approximation and third approximation, and we see you get repeated concept where you stop your working at the third approximation here. And lastly, round off the x value to the 3 decimal. So you must know how to stop. If you add 1, you don't know. If you add 1, you do until x4, means you don't know how to stop your working. So this is the concept for us to see how many approximation you managed to do and when you're going to stop your working.